Hello folks, I'm Ed Overstreet. Welcome to the Night Sky Imaging YouTube channel. And again tonight I am out imaging both Jupiter, Saturn right now. And I'm getting ready to start getting some captures of the PacMan Nebula and pick up where I was last night. And I don't think my mic's working right. So let's get started. All right, let's head over to Sharp Gap, and here is our majestic Saturn, and gonna have to play around with focus. I just did slew to Saturn and start up guiding, and let's try seeing isn't all that good. Let's change our region of interest to let's try this, and I have no idea what I just did. We'll be going to Jupiter in a few minutes. Well, it'll be about 45 minutes. And Jupiter right now is in opposition. It's as close to our planet Earth as it's going to be for a period of 59 years. It won't be this close again for 59 years. If you're in the northern hemisphere and you go outside look to the east southeast about now, it's about 30 degrees high for me at latitude 34. And if I hold 3 fists up, it's about 10 degrees. It's about, a fist is about 10 degrees. And if you stack 3 fists up, one on top of the other, you'll be right on it. Then up and to the right, far right, you'll have to go probably another, it has an angle or separation, I think, of about another 30 degrees. Then you'll see Saturn much fainter, and that's what we got right now in our bead. I got echo. I'm hearing echo, so you're hearing echo. That should have fixed it. Welcome, Oral Biggs. Hi to you too, my friend. Glad you're on board. And welcome to the Night Sky Imaging YouTube channel. We'll see if we can't get... I gotta wait for it to settle down first, though. It's bouncing all over everywhere right now due to poor scene. So scene will come and go tonight. We'll have better scene on occasion, and then and as soon as it settles down, I'm going to try to work on focus. Last night we were imaging Jupiter and Saturn, and while the scene is bad right now, I'll head over to ooh, look, isn't that terrible? Actually, that's a cloud. Let me bring up PhD and look what's going on. Here's our Jupiter, but we're losing our guide star over here. We got a cloud going by. There it went. I knew it couldn't be too bad because I could still see, well, Saturn. Maybe it is too bad. There it comes again. Let me get rid of the trend lines. We'll wait it out, but I'll take that sound down so you don't have to hear it. Okay. Let's go back out and see if it's still, yeah. Scene is really, really bad, so it looks like it's really way out of focus, and it might be, but it's not that out of focus. It's just insane atmosphere right now. Maybe the dart has thrown asteroid dust all over my field of view. That was amazing. I was watching that over on the NASA television station at the NASA website before I logged on, or before I booted up and started doing this. While Saturn is trying to settle down, let me see if I can figure out how to go. Oh, we got to start this up. We're going to continue working on the PacMan Nebula. So let's make sure we already cooled our camera to minus 15. That's good. So let's slew. Let me bring out my outside observation camera real quick here so we can watch this happen. This is the big scope that's on Saturn right now. And I haven't started this one on the right yet. We're getting ready to do that now. So I am going to head over and we're going to slew to the target. And let's go right side again and wrong camera. And this ought to start moving, yeah. So it's slewing to the PacMan, which is, didn't have to go too far. And let's center it now. This is plate solving. Plate solving gets its name from when they would hold plates up to the sky, glass plates, and they had stars that were imprinted on the plate. And they would use that to hold and put the stars in the sky on, line them up with the plate to identify different things. Look how far I'm off. 19,000 pixels in right ascension and 417. Wow. We may not plate solve this after all. It's got a lot of work to do to center this. I tell you what, the plate solving software though is phenomenal. Let's see what we got. Yeah. Oh, we're down to 12 pixels off in RA and 62 in DEC, so we're getting there. I like to get my total error under 50 pixels. So that is such a small error. It's really easy to stack. It's really easy to stack images I took last night onto the images I'm taking tonight. Now we're 1 pixel off in right ascension and 2 pixels off in declination. So you can't get better than that. I can't get better than that. So let's run this sequence. It's going to start guiding. Let me go ahead and turn it on. I'll help it out, speed things up. And it's going to focus. We'll sit here and watch it while the scene conditions over on Saturn hopefully improve. It's going to run a focus routine, although I think I'd almost rather watch paint dry than to watch this. But if you're not sure what's going on, I have a electronic focuser by Moonlight. I use those on I have 1, 2, 3, 4, 5. I have 6 telescope camera kit combinations that I interchange, and there are Moonlight focusers on each one of them. That's how strongly I feel about the machinery. They're just quality. And I can't do it with my eyes, and I'm not one of those that has a lot of comfort with a Bahtinov mass. It's easy to get the spider right, but it doesn't always translate into a good HFR. So I was thrilled to be able to trust algorithms built in these software programs that do the focusing for you, and it takes the guesswork out of it. And what it's doing is that it was pretty much focused because I was using the same focus point that I used last night. And what it did, it racked the focuser out 60 steps, and as that I have it set up to 60 steps for this kit, and then it brought it back in a few steps and took a picture, and the focusing improved. It went from 7, go over here, 8 this was the first image it took. This is the second image to probably 6 something. Then it racked it back in again, and it racked it back in, and then finally it got to a point where it wasn't going to improve the AHFR, so it's now racking it in and taking a picture, so it will gradually defocus again. And when it's done, there will be an intersection of these two lines, and at that intersection is the point of the best focus. With a 99% rating, it's suggesting that the focuser be set at step 8024. And right now it's at 7784 because it's defocused. It's racked it in, taking pictures. So takes one every 15 seconds on these hydrogen alpha. The narrowband filters I expose for 15 seconds. The broadband RGB and L filter I focus for about 6 or 7 seconds. Now it's taken a validation exposure with a 97% certainty. The best focus position for right now is 8021, and so it's set it to 8021. It's taken a validation exposure just to make sure, and so it's confirmed it, and it asked me if I want to run it again, and I don't. I trust it, and so it's counting down because it's going to start taking, it's going to, when it's focusing, it disables guiding, and you don't want guide errors to be sent in the middle of trying to evaluate a star's centroid, or it might jump around. So guiding stops. It's not so, I mean, you may have some deck movement or some RA movement. That's okay, it can account for that, but the sudden jerks from a pulse from guiding, it can't. So you disable guiding, and then it, you know that you've moved off of your perfect plate solve, so it plate solves again. Now it's done. It's down here, it's telling me it's resuming the guider, and now it's setting the HA filter, which is right here. So we focused, we've plate solved again, we're starting guiding, and now we're taking our first image. And last night, we don't need to check these. Last night we took our RGB images. These will be my stars. I took 8-second exposures, and I will process the stars independent and separately. And then I'll process the HA and O3 and S2 data separately. And when I'm finished working on these, when I finish working on the narrowband image, then I'll remove the stars and from that image, and I will add these stars. I'll actually remove them from here too, and I will combine the RGB stars, which have color from the red, green, and blue channel. They won't be as saturated because they're 8-second exposures and not 240-second. They'll be tight, sharp, and I'll add those back. So these are my star only exposures, and that's all I use them for. And then these longer exposures will be for the main target, the nebula. And this is the plate solve picture that it took when it validated. You actually can see some of the nebula. If we stretch this high enough, you can see some of the nebula even in a 15-second exposure of HA. So that's pretty, no, that was a lume filter. It plate solves using the luminosity filter. So it's pretty cool. I use a low stretch when I do these. All right, let's go over and see if the the scene's improved and we can get something going with Saturn. Oh yeah, it has improved some. So we've got Saturn, and I'm going to get closer to Saturn, and in doing that, it'll help me focus better. It just sent a guide pulse correction. And let's get down here and let's see, we're at 1120 steps. So I want to remember that in case I have to get back, because that's not too bad. Let's move out 5 steps. If I was outside looking at the focuser, the knobs that you can actually manually turn, you would not notice the move at all at 5 steps. You can't even tell it's moving. If you put it on 10 steps, you can just barely see a movement. That's how finite these focusers move. You can't do that with your fingers. And that's the problem with the Bahtinov mask too, is that the spider, you have to have a very bright star so that you get a spider that is so defined that you can really divide the spikes right down the center and get a good, well, it's better than nothing. It's better than trusting your eyes. Okay, we're going to go in. Hello, Ethan. Yes, that's my telescope. They're in my backyard. I'll show you what they look like. I have an observation camera out back. I have 2 of them, one on the clouds and one on the clouds and one on the telescopes. Since I'm in the house upstairs, this house goes upstairs, and I'm in a room as far away from the telescopes as I could be, not by design, but that's the room that was big enough for me to kind of put my observatory in the house. And these are, this is on Saturn right here. This is a Smith-Cassegrain, a Celestron Edge Smith-Cassegrain. And you can see the focuser, electronic focuser here, and then there's one, this is the filter wheel that's in the way. This is the controller for the moonlight, and there's one over here mounted on the saddle. And this is a Stellarvue 70T refractor. It's very wide field. By the way, we might be able, yeah, you can see, Fernando, you can see Jupiter really, really well. With it's bright. It's the brightest object in the sky, no question. So you can, wow, it's terrific, really, to think that it is as close as it's going to be for 59 years. So pretty cool. Okay, I am playing around with focus, but I honestly can't tell if it's any better or not. I'm going to go back the other way. The scene has improved, though. Let's see, I was at, okay. I already forgot where I was. I said I wanted to remember that. No, the focus isn't limited. I'm the limiting factor on my inability to know when to stop. The automatic focus routine works exceptionally well on stars. I don't know that there's such a thing for planets. And I guess I could run it. I could actually boot up Sequence Generator Pro, which is installed here. It's down here. I could boot it up and I could plate solve, not plate solve, I could run the autofocus routine. I'm not sure how this Planetary camera, which is the 224, I'm not sure how it would respond. This is actually looking much better. But at any rate, this is Saturn live. You are going to see Jupiter live, and I'm going to start taking some images of Saturn. I'll try now, and I'm not very hopeful they're going to be all that good because of the porcine, but I'm going to do it anyway because the fun's in the trying. And then I'm going to go out and we're going to not go out. I'm going to slew over to Jupiter, and we're going to take a look at it together now that it's as close as it's going to be for 59 years. Pretty cool. And what else was I going to do? Oh, I'm going to process one of the Jupiters. Let me get this started. So let's capture, start capture, and let's Saturn. Let's take 3,000. Actually, yeah, 3,000 frames. This will be a 3,000 frame video file. Sound like I'm wearing false teeth. I hear the between my. I've got one of these things on the mic, but at any rate, I apologize for the way it sounds at times. Sequence length. Let's take 10 of these, and we'll have an interval of 10 seconds. We really don't need it. We can just go to town. But so we're often capturing. And what I'm going to do before we do anything, let's go see what. Okay, here's our first image of the PacMan coming in from. Might be our second image. Let's see. Yeah, we had 25, so this 27. We're working on our 28th image. I want to get 60 of HA, which is I need another 7 hours of data, and then I'll have about 15 total hours of exposure time, not counting the stars. And but here's what it's looking like now in HA, hydrogen alpha, and we'll give it a little boost. So that's the PacMan Nebula. The stars are looking nice and tight. I really probably didn't need to shoot stars because this wide field has a 336 millimeter field of view. Where you really need to shoot your RGB stars are when you have these long focal lengths, and you also have not just long focal lengths, but you have you're required to take longer exposures a lot of times on these Smith-Castle grains because without reducers they're at f10, which is slow. So you might have to take 10-minute exposures. Well, 10-minute exposures will blow out your stars. So for that reason, and they'll be bloated. So that's why I take 15 or 20 second on a Smith-Castle grain. When you're up in 1,600 millimeters and 2,000 millimeters, I'll take the short exposures for the stars, and then I'll add them back in post-processing. I don't know if it makes any sense, but I do videos on how, I've done some videos on how to extract the stars and then put them back in. They're not live videos. It takes too long between steps to do these things live, but they're in there somewhere. What else was I going to do? Oh, all right. So now we have our two telescopes at work right now at the same time. I'm running two at the same time. Here they are. I've got the Smith-Castle grain on Saturn. That's the big one. And then I have the stellar view, the refractor. This is a reflector. This is a refractor. this is like a lens on a camera. It does have lens elements up here up front. And this has no lens, it's all mirrors. There's a primary mirror behind and a secondary mirror up here. And the light comes in, hits the primary, goes up, hits the secondary, forms a cone, and comes back and strikes the camera sensor. And that's where you get the long focal lengths. But all they do is capture light. So they're amazing instruments. All right, now one other look at before I go do something crazy here. Let's go back over. This is the stellar view refractor taking pictures of the PacMan Nebula, and this is Saturn, and we're taking pictures at the same time of Saturn. So if you look down here, we're capturing 2,200 frames, and we're going for 3,000, and then it will take another one. Okay, I'm going to take you to another computer if I can. I don't know if I can. Let me find the... Yay, I can. Found it. All right, this is another computer, and I just ran AutoStacker on Jupiter. And so what I'm going to do is minimize this because I have no idea what it's going to look like. I'm looking at this for the first time just like you. I'm going to bring up Registacks, but this is a picture of Jupiter that we took last night. I just haven't had a chance to process the data, and it's taking its time opening. Why do things like this happen when you're live? I think it crashed. Huh. Oh, I got two open at the same time. All right. Okay. So let's go select. By the way, this is one of Saturn that I took last night. And I did process some of those. So this is, and the scene, they're not going to be any better than this because the scene wasn't very good last night either, and it's just not that it's not real clear. So it is what it is. But let's open up the Jupiter we just did, and Jupiter, I kept 15%, and here it is. All right, this is Jupiter from last night. Let's color balance it and bring out the right colors. And now let's run a histogram. Not much because it's fairly bright, but let's stretch it there. That's all we needed. I'm going to bring up the curves and right click and right click, and I'm going to make a little slight S curve. Okay, like it. Then I'm going to rotate it some because I don't like this flat look. So I'm going to change it slightly. Wrong way. Still the wrong way. It's more like it. All right. Now let's add some wavelets. And I'm going to go down to Jupiter from 918. I've got a bunch of different templates. And this will sharpen it up some. Not a lot. All right, so let's add a different scheme. Again, just not real good. Let's go to the very first one, which is pretty radical. It's moving all these sliders over. And there we go. It's a little better. Let's add some sharpening. in each of the wavelet layers. There's and now we're introducing a lot of noise to it, which I don't like. So to combat that, but that's bringing out a much sharper image. But to combat that, I'm going to do some noise reduction down here. I already had a little more. Probably down here we'll add some noise reduction because, yeah, this is where we need it. Let's add another. Okay, not too bad for as bad as scene was, but it is what it is. Now let's go back and process one of the last ones we did because we had the giant red spot, and we'll just pick the very last one, and let's clear this, and this is what it looks like, and there's the giant red spot. And I want to scrub through this and see if I can find a better frame. This is a video, so I'm actually just moving through the video. That looks pretty good. So it's analyzed this. So this is what I do after I take these images, these videos, is I load them up into this software, and I convert them into a TIFF file. Then I bring them either into IMPPG or Registacks, and I apply wavelets, and I color balance. If you're using a one-shot color camera, always make sure that you select any one of these. But if you know your barometrics, use RGB. If you have a mono camera, I don't care. Make sure you select one of these even when you have a mono camera, because it will convert your image to RGB, and you won't have to figure out how to do that later when you combine your mono images together to make a color image. So always in AutoStacker, force one. You can pick any. If you have a mono camera, it doesn't make any difference which one you use because it's a mono camera. Just use one of them, so that it will automatically convert your mono image into RGB, a color image. It won't be colorful; it'll still be mono, but it will not. It will not be grayscale. It will be RGB. I know that didn't make sense. Just do it. All right, now I'm going to use 48, which is the size in pixels of the box that's going to be referencing the points of reference on Jupiter that's going to help it stack. So I'm going to place an AP grid. So these are the, just do an automatic one, and I'm going to stack it. It's going to take it a few minutes, and while it's doing that, let's head back over to our refractor that's taking pictures of the PacMan Nebula, and right now we're on 29 of 60. We started at 25, so we've taken 4 240-second images, and we have 11 seconds remaining in this image, and we'll watch it download for us. So it's 4, 3, 2, 1, and it's going to download another one. And it's running a dither. It's real critical that you dither between images. And the reason for that, and you have to do it with one-shot color cameras, you have to dither. You can get by without dithering every frame with mono, but you can't with one-shot color, because you're probably going to separate the channels into 3 mono images in post-processing so that you can work on them and get rid of the halos in your stars. And so you have to dither to do that. Now, what happens when you dither is that the mount is sent by, in this case, by Sequence Generator Pro, I've got it set up in auto guide to do a small dither after every frame, and so it will settle at 7 pixels for a period of 5 seconds, and it'll start again. And what it's doing, its PhD is sending a signal to the mount to move it a few pixels. And so the mount's actually moving a few pixels. You think, well, why would you want to do that? If you have dirt on your sensor and you move the mount, the dirt moves with you. And because the dirt's on the sensor, the dirt's going to go where the telescope goes. But the stars will be in a different place. And so the software identifies what's on the sensor and what's in space. And when you go into post-processing, it takes those dithered images, identifies the crud and the crap that's built up on your optical train, and it removes it. So dithering cleans up your image and helps manage the noise. So it's just a must to do it. A little bit of an aggravation. It adds downtime to your imaging, because in this case, it says I'll be done in 6 hours and 37 minutes. And if I go up to my planning tool, and let's see, we're right here right now at 41 degrees. I'm looking down here. And every one of these lines represents 1 hour. So we have about 30 minutes here. So we have 1 hour, 2 hour, 3 hour, 4, 5, 6, 7.5 hours before I start getting some daybreak. So 7.5 hours, and then I have about 8 hours of imaging time, and I've got about 6.5 hours to do it in. Now, if your math would tell you, well, you've got plenty of time to get all your imaging in, but I got to focus between filters. So I have 3, and I'm going to focus every 2-degree temperature change. So that's downtime. And then if you're going to dither, that's going to add another 15-20 seconds to each exposure. So you need to add about another hour onto your total time, because it's going to take that long. And in this case, I got 6 hours and 36 minutes of imaging time. I really have more like 7 hours and 30 or 40 minutes that I got to get it in. So I don't know I'll get it all in. And I will shut this thing down. In fact, let's go ahead and set it up now so I don't forget. Wrong screen. I want to go to the planning. I'm going to go over here about right there, and I'm going to right click, and it's going to set a mark, and it doesn't make any difference whether it's finished or not. It's going to stop imaging right there. You can see right here, it put a check in the end at 6 o'clock. So tomorrow at 6 o'clock, whether I'm done or not, it's stopping, because it's pointless to image if you start getting light in your image. The frame's going to be useless. So it's going to stop imaging and park my telescope and turn everything off, everything but the dew heaters. So that's done. And now let's head over and see if we still got oh, we finished. This was an image I was doing, and we're done. So let's minimize that. And let's go over to, this was the first Jupiter that we did. Let's save this as Jupiter JP, and we're just going to put 9, 26, 22. So I'll recognize it. And then let's add the one we just did, which will be that one. This has the giant red spot. And there's the giant red spot. Let's, I wonder if, I don't remember, I have no idea what I flipped, what value I used when I flipped or I angled. That's too much. Let's bring it back. Too much. I'm going to have to do them over again anyway, because I have to have this exactly right. I'm going to bring it into WinJuPost. Okay, let's color correct it. And so we want to color balance and just click auto balance. Bingo. Now we want to take gamma and we want to right click, and that's my S curve, with the exception of, I'm going to have to reset it, screwed up. Reset, hold still, Ed. Okay, and I want to right click and create another set point, make an S curve, add a little contrast, make it a little more. Alrighty, let's add to the histogram just a little bit more light, and I'm going to drag this slider to about here and stretch it. And so done, done. That's it, 357.4. All right, let's load that last scheme. There it is. And let's see what happens. Bingo. There you go. And so we have Jupiter that we did last night. And even though it wasn't the closest, that it wasn't as close last night that it is right now. It was pretty close. So they're looking at Jupiter, and this was an image we took last night. So now let's go out and see what Saturn's doing. If I can find it. I'm running too many computers here, so let me see. Yeah, here we go. We want to go to number one. Number one is, there we go. Now, actually, let me put these on different screens. Number one, let's put there, and let's move it over, and let's move this one up here. Just have to bear with me. I'm running way too many screens. I've got 3 different computers that I've lit up, 2 outside, 1 for each telescope, and then okay, we have 1 remaining. We have 1 image remaining. So you're looking at Saturn live. It's not nearly as I can zoom in more, a lot more as a matter of fact, but it doesn't really help to define focus. In fact, I think in some ways having it zoomed out some kind of helps in the focusing. I've tried everything under the sun, but see the movement that we're looking at right now, the instability in the atmosphere, that's light dispersion, is what I'm told is the bane of photographers shooting up, because it's just very unstable. I'm getting some good ideas. Yes, it's in Louisiana. Sure is. If you'll go outside now, to look at Jupiter now, go outside and look in the east-southeast, probably more south. It's moving that way now, between east, southeast, and south. And put your fist out in front of you, and then take your other fist and put it on top of that, and another fist on top of that, and you'll be right on Jupiter. So get your compass, go to the east-southeast, and take 3 fists, because it's about 30 degrees high, and each fist extended is about 10 degrees. And but it's the brightest light in the sky. There will not be another light brighter than Jupiter tonight, by far. But you are looking at a live view of Saturn, And pretty cool. All right, you ready to go see Jupiter? I finished this, so let's bring up my planetarium software. And here's Jupiter right here. And so what we're going to do is I'm just going to go ahead and put it there. Before I leave, though, I want to let me go back to Saturn. I need to do something here real quick like. And I should have already done this. And sync it so I can be right on top of it. All right, now let's go to Jupiter. And let me make sure my cameras outside are ready to roll. And you'll see this camera move from here to over in here. So let's go activate the slew and click on slew. So it's moving. You can see it here moving, and then we'll go outside. And there it goes. All right, we're on Jupiter, hopefully. Now let's go back out here and bring up PhD. And let's top that, clear that. This is Jupiter and its moons. You can see several of its moons. It has 56 moons in all, so let me bring this to level 2. And let's see, we want to go east. No, I guess we want to go west. Yep. This is a 160 millimeters, so I have a wider field, a wider view, and it allows me to center it a lot better since I'm not outside and I can't look through a guide scope. I mean a finder scope. All right, let's see. We want to go. I guess we want to go north a little bit, then go east again. No, wrong way. All right, now let's go up. Forgot what up was. Wrong way. Yeah, I'm dyslexic, guy. All right, now let's go out to Shark Cap and see if it's anywhere in. All right, there it is over there trying to find its way in. So it's so much brighter that I'm going to have to dumb down the exposure. And I also want to, let's go down to auto and let's, somebody's offered me some suggestions, and I haven't had a chance to look at my comments, though. I will in just 1 second. Let me figure out how to get this. All right, did that right. Now let's go up. Yeah, I just need to get this centered. Let me change this to 1 times sidereal speed. Okay. All right, now please tell me I'm going the right way. No, I'm not. Oh, okay. Little more. All right, let me activate guiding out here, and let me Stop, loop, click on this, find a guide star. Oh, we found one, and I think it's a moon. We'll find out in a minute because the guiding will be nutso. I think I'm on one of Jupiter's moons. Let's see how. We'll give it a second and see if. Okay, all right, let's go back out and take a look at our hot planet. And it's awfully. Oh, we got the great red spot. And we can also get bigger here. I've got windows that I'm looking at that you guys can't see. It's part of my streaming software. Hey, Jim Miller. You gotta, let me find your comment here. Let me come over here to, just give me 1 second and I'll be able to get all these comments where I can see them. Yes, Anna, those are the moons. I'm in Spartanburg, South Carolina, Ethan. Okay, I'm afraid I understand my mic is choppy. I was getting some feedback, and I'm going to move it. I'm going to move it around. It looks like to me that it's just. Let's try this. Let me know how this is sounding because I've dumbed it down some. But I'm going through y'all's comment. Thank you for subscribing. I appreciate it. I don't know if these are any good or not until somebody subscribes, and that gives me motivation. Look, I'm 78 years old. I've retired. The life's been very, very good to my wife and myself and my kids and my grands. I'm out on YouTube trying to make any money. I don't know that you can, but I'm in here because I love astronomy. I'm passionate about it. I love doing it, and I love sharing it and telling other people about it. Yes, you can see it in New York City, but Bappy, I don't. You got so much light pollution, but I do think you could pull it out. Just look south, south, south. I mean east, southeast, more towards the south, but it's on the eastern side of the southern meridian, and it's about 30 degrees high, and that's about 3 fists. If you extend your arm way out and put one hand on top of the other, um, you'll see it. So. It would be beneficial if you had a weather balloon and could get away from the light pollution. But one of the reasons why, Emmett, they put rockets into space, you'll notice that the rockets that they put in space, for the most part, don't go into deep space. They just need to get out of our atmosphere. We do have some that are traveling into deep space. Joshua, I answered your question. We have Jupiter. Oh, let me get over to Jupiter, by the way. There you go. I'm sorry. Yes, you can see Jupiter. Um, Let me go back to, how can I keep, I don't want this. I want, well, heck. Why is it doing that? All right, hang on a minute. Let me read through the comments real quick here, and unfortunately, you're going to have to see an image I processed yesterday, and then I'll go right back to Jupiter. I think I know what I can do. Hang on a minute. I might get too fancy and screw the whole thing up, but I'm going to try to do this. Okay. Now, I do want to do this, though. I want to bring up a program called WinJuPost. And I want to go to Program, Celestial Body, and go to make sure Jupiter's clicked. I'm going to go to Tools and click on the Ephemerides. And so I want to click on Real Time. Yeah, this is what we're looking at right now. This is Jupiter as it looks right now, and this is the giant red spot. So I wanted to confirm that's what I was looking at. Now we'll go back to, and this is the giant red spot right here. So it's kind of hard to see, but it's there. So let's start taking some, before I do that, let me see if I can better my focus somewhat. I'm moving the focuser out 5 steps at a time and pausing just to see if the bands are more defined. And that's about all I can do, and I don't think it made any difference. So we're going to go back in the 10 times. And let's go back the other way. Oh yes, this is getting better. I was just heading in the wrong direction. You can see the North Pole pretty well too now. And yeah, this is a little better. Let's see if, okay, good. Oh yes, I need to go back and retake Saturn now that I have found a sweeter. Oh yeah, we can. Okay, yes, good. I'm a little bit full of myself because this is going to be okay. So let's go to capture, and we're going to start taking some images. And let's take 5,000 frames, and let's take. This is a special night, so let's take 20 of them, and let's start. And it's on. Now I'm going to go back and try to figure out how to see the comments and Jupiter at the same time, so bear with me. And I know I can. I just this is the image you're looking at that I took last night, or one of them. Tell you what, I still haven't figured it out, so I'm going to go back again and just look through the comments. You can see it. I think I answered in Baton Rouge. Yes, sir. If you're in the North America, if you're in North America, you can see Jupiter right now. It is about 30 degrees altitude, which is about 3/5 extended, stacked on top of each other. The red spot moves. Jupiter rotates once every 10 hours and change, where Earth, our planet, rotates once every 24 hours and change. And so when it rotates, the great red spot, which is a storm, a 500-year-old hurricane, cyclone, that storm comes into view. So, yeah. So we don't always get to image it. We have to be lucky. And the moons also, we can also see the moons when they get in front of Jupiter. Jupiter's lit up by the sun. All planets are illuminated by the sun. And when one of Jupiter's moons get in the way, eclipses Jupiter, then you can see the reflection, you can see the moon, and you can see the dark spot on Jupiter, which is the moon shadow. And those are always cool, and especially cool if you can get that and the great red spot in one image. Yes, if you're in Long Island, yeah, for sure. Make sure you go outside and see it. Don't stay in here and look at this. Go out and see it for yourself. It's a once in a. Thank you, Ethan. Appreciate the comment. Thank all of you guys. Okay, now let's see what we're doing. Again, this is what we imaged last night, and so we're going to go back out to Jupiter, and I'm going to hush for a few minutes, and I'm just going to marvel at this thing. Yeah, if you have a pair of binoculars and can get it has any reach at all, then make sure you lay them on something stable because it's hard to. Thank you, Tristan, for subscribing. It's hard to view. It's really hard to hold them steady, and that's why telescopes are on these mounts. And if you saw what I have in my backyard, I have steel piers that weigh about 150 pounds a piece, and for each telescope, and they're in cement. They're in 4 cubic yards of cement, and to keep from moving. And even with that, a car can go by with one of those bases that you hear the radio boom, 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 and it'll vibrate. I can be looking at, say, this graph right here, and a car can go by and I can pick it up on my outside observation camera audio, and you can just see this thing move with the boom, boom. That's how sensitive these things are to movement. So you can't hold binoculars steady enough. Now this is Jupiter and 3 of the moons, of which there are 56 total moons. So you'll never find a home on Jupiter because it's a gas. It's all gas. It's just gas. Now we don't know what's at the core, but it's not a rocky planet like Mars and Earth. It's a gaseous planet. But the moons are rocky, and life on one of the moons is possible if it's has water and an atmosphere we can survive in. Okay, we're back on. The Great Red Spot is actually rotating off. In the next hour, it will be gone. Maybe 2 hours, it'll be completely gone, and it'll head around to the dark side. Be right back. I want to. Okay. Let's see what's going on here. Okay, this is better. Let me well, fiddle. Keeps wanting to take me over to wherever. back over there again just for a second here. Let's, I think I've got everything over there I need now. All right. Emmett asked the question, isn't that a little excessive for capture? And are you talking about taking 5,000 frames? If that's what you're talking about, no, to answer your question, because I will keep probably between 10 and 15% of those frames, maybe 20%. If the scene is really good, then I may keep a higher percentage, but I don't have to take as many if the scene is really good. And the scene is not really good. It's gotten better, but it's not by any stretch really good. So normally, if I were not doing this, I would probably be taking some 10,000 frame up to 15,000 frame images, and I would make it darker. I would drop the exposure so I could get more frames per second, and that would be a big help. And then I can always lighten the histogram in post-processing, so I can lighten it back up, but I would be you wouldn't see it as well, and so I'm choosing to do fewer frames. But no, I think 20,000. I have a friend who is in our astronomy club who's one of the best planetary imagers on the planet. He is so good, and he takes between 15 and 20,000 frames of Jupiter, and Saturn he'll take 8 to 12,000 for Saturn, and sometimes more. No, I'm the one that gets by with fewer, and it's mostly because of impatience. Planetary imaging is not a strength of mine, not that I have many, but it's just not a strength of mine. I really do enjoy deep space imaging, and speaking of that, I need to go over and make sure I haven't crashed with the other telescope. Okay, this is the other telescope that's outside, the refractor, and we're taking some deep space images. This is the PacMan Nebula, and it's NGC 281. If you want to look it up, see what it's going to look like. Actually, we can head over to, there I am, we can head over to Astronomy and check in, and we can search for NGC 281, and we'll look at what I'm chasing. And here's looks like what there's the PacMan. So that's what I'll have, something like this when it's all said and done. Oh, hopefully. That's why I'm spending 15 hours on it. So there it is. Zoom in a little bit. He's rotated a little bit differently than I am. It's you almost have to flip this horizontally to see it from the angle of the picture on Astronomy. Let's go back to Jupiter. So let me see if I can find some more of the comments. I apologize if I haven't gotten yours. No, I image Jupiter this time of year, Ahmed, every night that it's clear, and hoping that I get the best scene I could possibly get. I'm always looking for a really good scene night because there's so few of them. There are just not that many. And that's when you really get a sharp looking Jupiter. But this is a once in 59 year event that Jupiter is in opposition. It's closer to Earth right now, today. Well, actually at 3:16 this afternoon, Jupiter was closer to Earth than it will be for another 59 years. So that's it's a once in my lifetime event that it's this close. Now, I'm not sure I understand how YouTube actually works. Thanks, Destiny, for the feedback on audio. I'm not real sure how it works, but I hear what other people say. If you subscribe, I think you'll be notified if I put another video up, whether it's live. Then I hear people say you have to ring a bell. I don't know. I've never rang anybody else's bell. I don't know. And I know I get notifications from channels that I subscribe to. So I don't think you have to ring a bell, but I don't know. But thank you for subscribing, Ethan. I think I already thanked you, but thank you. I'm just reading through the messages. I got you, Joshua. Oh, I have. I started out imaging the moon when I first started, which in this hobby, which was in 2009. My son had sent me a telescope. He lived in California at the time, and he sent a Vixen ED81S refractor, which is still today one of my favorite telescopes. And I do a lot of photography. I did it as a hobby and retired from a career in financial planning in 2000. And so I took up my hobby and I built a sports photography business. So I do a lot of sports photography still. And but he sent me a telescope, and I had just had hip replacement surgery, and I was laid up. And as I started moving around, I really never thought of. I never really. I don't know. I was wondering, why did he send me a telescope? I didn't know much about. I knew which end to look out of, but I didn't know much more than that, with a mount and all these instructions and things. So at any rate, I had plenty of time with the hip replacement to try to figure it out, so I did. And I had it out on my back porch, and you really don't want to put a telescope on a porch if the porch moves when you walk, because then your field of view is moving. But I did. And I got the moon. And I ran in and got my wife, and you're not going to believe what I'm looking at. Uh, I was actually I could actually see all the craters up close. And I went and got her, and when I brought her out there and she looked, it was gone. She said, I don't see anything. It just looks black. And I said, no, 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 you got to see it. And I looked and it was black. And that's when I realized everything's moving. So I had to figure out how to plug in the mount and get it to tracking, because you just couldn't hold it. It leaves the field of view right away. So that began my journey, and I started uh, hooking up a camera. Now back then there weren't many YouTube channels on photography, on astrophotography, and so a lot of this I had just to figure out myself. And there was an astronomy club in Greenville, but they were visual. They didn't do any astrophotography, and so I was about the only one in upstate of South Carolina that I knew doing this. And so a lot of trial and error, a lot of purchases I should have never made. So that things that it is green, Go Cat. It is green, but when I process it, all that color gets corrected. It's the atmosphere between here and there that helps shape that color. But when I get into post processing, uh, hang on, I don't want that. Right here, this is an image I took last night of Jupiter, and so I color corrected it and we cleaned it up, and we only kept some of the better frames. So I took 5,000. I think I kept 15% of the 5,000 and stacked those on top of each other in order to render a reasonable image of Jupiter. And this is the great red spot from last night. So yes, it will look green until we color correct it. Now, I'm told by a friend in Belgium that I can move these, I can control these, I can balance everything from down here, but I'll wait till I get in post-processing to color correct it. The great red spot's clearly moving across the face of the planet. No, seeing is more than light pollution. That's a problem, Ethan. Light pollution makes your sky look kind of mucky, and so you get a. It's hard to get signal, and more especially, light pollution is a problem with color, one-shot color (RGB) imaging with broadband, because the light pollution comes in along with the red, the blue, and the green. Now, in narrowband, that band is so narrow that light pollution is not nearly an issue that it is with RGB. And in Planetary, the exposures are pretty fast, and so I'm able to, I put light pollution filters on the telescope, and as they do a pretty good job of filtering out some of the pollution, because I'm near a fairly good sized city, nothing like a New York, but light pollution exists nonetheless. If you know anything about Bartle skies, I'm in a class 6 Bartle sky with a sky meter reading of about 19 at the best. 18.9, 18.8, 19, 19.2, something like that. When I do a sky meter rating in my backyard. So narrowband imaging like I'm doing on the PacMan, that's not a problem. The problem of seeing is the atmosphere has so much turbulence that it's moving. When you see a star and it's twinkling, that's a seeing problem. If a star is not twinkling, that's a good time to be imaging. So think of it this way. There's a lot of heat coming off of rooftops. Excuse me, I'm going to have to mute me. And that kind of stuff that is in the atmosphere, thermal dispersion and plus the light pollution, all of that just creates an unstable atmosphere. And so you see the planets moving around. If you've ever seen the moon through a telescope and you're doing that in bad scene, then it just looks like it's underwater. That's kind of a, it's just not sharp, clear, and it doesn't have a lot of clarity. So, but seeing conditions more involve the transparency of the atmosphere and the light dispersion due to issues due to our atmospheric dispersion due to thermal and other kind of interference between my camera sensor and the target. When you consider how far away this is and how much light's traveling to strike my sensor, that's pretty impressive that it's this stable even as it is. Uh, but it can be even more stable, and I've seen it when it didn't move at all. It was just dead still, and you could see the definition of the bands and this, any other object on the planet. And that's when imaging. That's why I come out and try to image it as often as I can, because I'm hoping for one of those rare moments where the scene is just near perfect, and you get those good captures. But when it's not, you take a lot of frames and keep a few, and you just keep the very, very best. And the software that I use does just that. It calls out the bad and keeps the percentage you want to keep, if that makes any sense. And so we have Jupiter, and we're in the middle of an imaging session. I'm taking 20 movie files, and each movie file is going to be probably 5 minutes long and 10,000 frames. I will keep probably 1,500 frames and get rid of the rest, and stack those on top of each other to make an image and bring out the clarity. But I can already tell you that just from looking at what's going on here, that's not a whole lot different than what I was dealing with last night, scene wise. And the best probably I was able to do last night, I just showed you, which is this is the PacMan, which is this image here. So I just processed this one a few minutes ago, and I overset. It's blown out. I probably should not have used the histogram, but it did. I won't do that on the next one. Okay, let's go back to Jupiter. Oh, let's go over and see where we are with. We're on number 41, and I took 25 last night of HA03 and S2, and so I'm going to take. I want to have 60 in all. I got 5 hours, almost 6 hours of imaging left. And that's going to take me up to close to 6 o'clock in the morning. So I will be in bed sound asleep, and this will still be going. And when I wake up, it'll all be done. And if clouds come in, and you're not usually going to have rain unless clouds come in, then this is set up to to call me on my cell phone and let me know that it's shutting down due to clouds. And I'll check and see if it's getting ready to rain so I can go cover things up. Pretty cool. I wish I could take credit for some of this software. It's hard enough to figure out how to use it, let alone write the stuff. It's amazing. Okay, one more look at the PacMan, and then we'll go back and just stay on Jupiter for a while. Let's fit the screen, and we'll go back and just let Jupiter have it. There he goes. Yes, Shauna, it's visible in Alberta, and it's going to be a lot higher in the sky there because your latitude is so much higher than ours is. Um, so it's lower in the sky if you're in Florida or you're in near the equator. It's on the horizon. But if you're in Alberta, it's a lot higher in the sky. I'll tell you what, just look towards the south, and it's the brightest object in the sky, bar none. There's nothing in the sky, unless it's a space shuttle coming by, that's going to be brighter than Jupiter. And I'm not even sure the space shuttle will be brighter. It's pretty bright. But Jupiter's not moving like the space shuttle does. Yeah, Ethan, the software is it's crazy. Okay, and you know, one of the fascinating things is most of it is free, written by astronomers for astronomers, our astrophotographers. It's free. Now, SharpCap has, I think, a $15 annual license, and that's the software I'm using here. But AutoStack is free, RegiStax is free, IMPPG is free, PIP is free. Now this software over here called Sequence Generator Pro, that does have a an annual license, and it's the most pricey. I think it's about $200 to buy it, and I really don't know. I'm not sure. It's like $200 to buy it, and then it's something like 50 or $60 a year. But they're updating it all the time, adding new bells and whistles. It's worth it, and you spend the money on astronomical cameras, telescopes, mounts. It's pointless to be chintzy when it comes to getting software that will produce your images. Half of it's capturing it. The other half is figuring out how to take the captures and turn them into a pretty image. Uh, yep, back to Jupiter. I have a website called nightskyImager.com. It's one word. And I've got a lot of images of the sun that I've taken, of deep space, and also over on Astrobin. If you look up Edward Overstreet, I don't know how you find me on Astrobin. That's a good question. Let's see. That's me. I'll go to my Astrobin site, and that's me. That's me when I was a little younger, but that is me. And here's the monkey head nebula. But if you just go over to Astrobin and look up Ed Overstreet, I have some time lapses I've done of the sun and these fiery flares coming off of the surface. I enjoy doing that. I do a lot of solar imaging. I go live all the time doing that. No, I wasn't live today. Is this the this is the monkey head again? I've got the PacMan up here too. I've taken in a number. Here's one of my favorites, the Rosette Nebula. It's one of the prettiest. And beautiful part of the sky. All right, back to Jupiter. You can see the great red spots moving moving around. Yes, it's visible in Calgary. It's really high in the sky, higher in the sky. Uh, sure is. Yeah, if you have a pair of binoculars, it's happy birthday, Walt V. Disney. That's cool. Uh, see if I can. You can see it in Nebraska. It's going to be probably about 40 degrees high because you're a lot higher. That's all. Wish you a happy birthday, V. Someone, and I forgot who it was, but someone said, "What's with the blurry image in with the telescope?" Unfortunately, the video imaging that I'm doing is blurry, and that's why I take so many frames, and I extract those frames to stack it to make an image. But this is what you ultimately come up with, something like that. So that was Jupiter, a picture of Jupiter that I took last night, and it looked just as blurry when I captured it, but only keeping a small percentage of the frames, stacking them, you can come up with something that looks okay, even in bad scene. This is not a real good Jupiter, but in fact it's better than I thought it was going to be. And the Jupiters that we're going to take here tonight won't be a whole lot better, maybe not any worse, but it's not going to be a whole lot better either, I don't think. Unless the scene really gets terrific later on in the evening, it might. You can see it in Egypt. Yep. There's not a place on the planet you can't see it, except around the equator. And then it's so low in the sky, you're going to have to get up on something. You're going to have a clear view of the horizon. It's going to be very low on the horizon. Yep. Binoculars can help, but you need something stable to set them on. I don't know, is there music coming through? So Destiny, you can hear the music? Oh. Well, I'll hush and listen to it. It's not coming through here, so I don't know what I've done. Thank you, Ethan. I may need to I can't hear the music, so I've selected it, but I can't hear it. So um, that's nuts. Destiny, I can't tell if it's playing or not. I can see it on my soundboard that it looks like it's playing. It's just not coming through my headset. But I think I've got some issues with the board. It may be more technical than I'm capable of solving. Let's go ahead and we don't need the hand controller right now. That's a special planet. We talk about the some of the insane statistics about those things in space, and our sun, our star, is is huge. It's 93 million miles away, and it's huge. And yet, the moon is 400 times smaller. And when we have an eclipse and the moon hides the sun, when we have a solar eclipse and the moon moves in front of the sun, it completely blocks it out. And it's because not only is it 400 times smaller, it's exactly 400 times closer. And that makes that eclipse possible. Isn't that cool? And the star, our sun, the star, you think of it being a big, big, big star. And it is. You could put 1 million Earth sized planets inside of the sun. That's how big it is. But our sun is really a small star in comparison to some of the big ones like Betelgeuse and Eta Canerine. If Eta Canerine was our star, it would reach past Jupiter. That's how huge it is. And you could put 1 billion Earths. No, you could put, let's see, how's that go? You could put 1 million Betelgeuses inside Eta Canerine. And you could put 100,000 of our stars inside of Betelgeuse. Eta Canerine is the largest star that we know in our observable. Well, it was. I think they've come up with another one, but it was the largest. CY Canis Majoris, not Eta Canerine. CY Canis Majoris is the largest star. Was the largest star in our observable universe. It is huge. Yeah, I had I did the last solar eclipse and streamed on the NASA website. NASA picked up my live stream. Sure did, Ethan. And then the last the one in 2000 and was it 18? August of 2018. Um, the images that I took of the eclipse went in newspapers all over the world, I found out. So, how I found out is that the local newspaper here, which is owned by the New York Times, our local newspaper knows I do this, and they asked me if I would send them some images of the eclipse. I said, well, sure. So I did, and it got picked up on the wire. Well, a member of our photography club has a sister that lives in Buffalo, New York, and uh, and she knew that my friend was part of this photography club, and our club actually went to a site. Uh, we went to a fire station down near Woodruff, South Carolina, which was right in the center of totality, and that's where we set up. And so the picture that went into the paper mentioned the Spartanburg Guild, Photography Guild. And so when my friend's sister in Buffalo saw the paper, the picture appeared in her paper, and underneath, of course, was taken by Ed Overstreet with the Spartanburg Photography Guild. She called him and said, "Aren't you with the Spartanburg Photography Guild?" His name's Phil, and Phil was actually with me down there then, and he took some pictures. In fact, some of his were better than mine, but I was the one the paper picked up. Phil took some incredible pictures, and but mine got in the paper, and then they paid me. Let's see, the paper paid me, I think it was $80 for the picture. I also send them sports pictures because I photograph sporting events, football, basketball, baseball, etc. And college, high school, used to do some NFL. And so I would send them pictures when they didn't have a staff photographer that could cover the game. And we had a pretty good working relationship, but I think they paid me, I forget what it was then, $80 for the picture. So when I found out that it was in Buffalo, New York, I called and said, "You know my picture's in Buffalo?" And the guy that runs the photography department said, "Yeah, it got picked up on the wire. You went in over 1,000 newspapers all over the world." I thought, "You're kidding me." Yay me. And of course my chest bowed out and I was proud of myself. Anyway, hey, Yvonne, it is in the Midwest. Jupiter is now in the south. In fact, I'll bring up this planetarium software. Well, I had it up. And, oh no, it isn't in the south. All right, we're gonna look at this. Here's Jupiter right here. This is south. This is east. So it's still in. If you take your Saturn, now right now, due south. Saturn is getting ready to cross the meridian. It's right here, and here's Jupiter. So Jupiter is going to be crossing the meridian about here, and I'm going to click on Jupiter, and I'm going to come down here and see it's at 37 degrees altitude. I'm looking down here when I hover over it. So the altitude is 37 degrees, and if you have a compass, it's 122 degrees on the compass. So it's 37 degrees high and 122 degrees southeast, and that's where it is. So now that's if you're at latitude about 34. Now, when you get your GPS out, you have longitude, latitude. All we're interested in is latitude. The higher up your latitude, then your Jupiter's going to be higher. So if I were located, you know, what I have to do when I set this up is I put in my observatory information, and my latitude in degrees is 34 degrees 55 minutes. And that's why it's showing me that it's right here at 37 degrees. If I was at 55 degrees or 60 degrees, like I would be if I was in Calgary or Alberta, then this would be appearing higher. And if I was close to the equator and was like 10 degrees, 5 degrees, it would be lower, closer to the horizon. If that makes any sense. Everybody needs to get a planetarium software program and learn to use it. This is free. It's called Cartes du Ciel, and it's free software. And it's absolutely fantastic. You can learn the night sky real easily. And you can zoom in. You can search planets if you want to click on the little search. And if you know it's M31, just type in the Messier number and find, and it will take you right over to it. There's Andromeda, M31. So it'll find anything in the sky that you can. I think there's some 40,000 objects in their catalog. We better go out and see if we still have Jupiter in our crosshairs. Oh, it's right here. Excuse me. Yep, we do. We got a little drift going on, which is all right. You know, we finished those images. We're done. How about that? We've taken this is tonight, 27th. We got Saturn. I never did put up. And then these are... Okay. Good. Here's a movie file of Jupiter. This should be Jupiter. Yep. So this is a movie file that we took just now of Jupiter. And all those checkers, all that checkerboard you see, just means that it's not debayered. Debayered means it hasn't been converted to color yet. So let's go ahead. The great red spot now has rotated off the face of Jupiter, and it's now going around to the dark side. So let's go ahead and start another capture. And we'll do another 20. Let me make sure that I changed this now to Jupiter because I forgot to do that a while ago. And let's create a new... I should have done this because I put them in yesterday's folder. And let's create a new folder for trying to spell with one finger. Okay, always select apply. Now let's take another 20. Start capture. 5,000 frames. I think a while ago I said I was taking 10,000 frames. I think I'll stay with 5,000. And I'm going to cancel this. And let's start it again. This time let's make sure we put Jupiter. And let's start. Thank you, Destiny. If if you're talking about congratulations for the picture, that was yeah, it tickled me. The lady in I had Phil ask his sister if she would send him the picture, the paper. So it's I don't know where it is now, but I think I carried it around showing it to everybody for a while. Uh, I haven't had many things published in my life. I get sports pictures on the local newspaper. That's about it. Besides the night work that I do, taking night sky images, I also take about 100,000 sport pictures a year. Process, upload, and send to whoever wants them. I put them on websites too that I manage. Yeah, it is. Isn't it cool? Uh, it's Powellen 92. I probably mispronounced. He said, I just saw the moons of Jupiter with binoculars. Yeah, it is cool. It is, it's crazy just to think that you can have so much fun in your backyard with a lounge chair and a pair of binoculars, and if it gets cool, a blanket. Or just head out to a dark site, go out in the country, pack some snacks, get your family, and invest in a couple pair of binoculars. And there are they're like tripods that hold binoculars very very steady. They're really worth it, and and they're not all that crazy expensive. Less than $100, you can get a set. I'm in Spartanburg, South Carolina, Marvin. Oh, I thought you said where are you? Um, can't read. Chicago. That's the coldest I've ever been in my life. I was going to graduate school at Purdue, and I'd have to land in Chicago O'Hare, and it's the hottest I've ever been too. Didn't have air conditioning in our house, and candles melted with from the heat. It was dirt poor. But there ain't anything like the wind blowing in Chicago off that lake when it's like 6 or 7 degrees out. Whoa, there's nowhere to go. You just die. You can't put on enough clothes. That's when I fall down on the ground and kiss South Carolina earth. But we're not without our weather problems. By Friday night, my telescopes will be covered up. I won't bring them in, they'll stay outside. But Hurricane Ian is headed right for our city right now, thus, it's changing courses. So we will be hammered pretty hard. We've been through hurricanes, tornadoes, and not saying it won't do a number on us, but I don't bring the telescopes in. I leave them out year round, 365 days a year, 24 hours a day. And I cover them up with covers called telegizmos. They're worth their weight in gold. Our HOA, our Homeowners Association, won't allow outbuildings, so I can't build an observatory. But this is a telegizmo cover. It's a 365 telegizmo, which means it'll keep your gear dry, moisture free, and in the summertime, it will be 10 degrees minus ambient underneath it. In the wintertime, it'll be warmer by 10 degrees ambient. They are extremely thick and they got several layers of stuff I've never heard of to help in the insulation. The only thing is that they tie down at the bottom. And again, these are steel piers that are bolted into 4 cubic yards of concrete, which doesn't sound like a lot. It is a lot. a bunch. This is a towel covering up 2 laptops. And these laptops, each one of these telescopes has a data cable plugged into the laptop, and then has a power cable plugged into an AC power out here. And so the data feeds the information that you're seeing into this laptop. And then I'm connected in my home at my desktop to both of these computers using a software program called Splashtop for business and by Wi-Fi. So it picks up my Wi-Fi. My Wi-Fi picks up this computer with a good signal. This is a solar telescope. This is the one I use for imaging the sun. And then I've got one in my garage that I roll out into the driveway that also images the sun, and that is in the front of the home. And that's where my toys are. This telescope right now is on Jupiter, and it's the one imaging right now Jupiter. And this one's on the PacMan Nebula, and it's imaging, and we better go check them both out. So Jupiter's going. Oh, Ethan goes to Clemson. Oh, heck, my next door neighbor's a bigwig with Clemson, with BMW. Yeah, and I'm on the eastern side of Spartanburg. I mean, on the western side of Spartanburg. So I'm not too far at all from, uh, can't even talk, from BMW. And I photograph a number of Clemson games. I go back to Danny Ford and 1981 national championship. I wasn't there. I'd get down there and do a game from time to time, but I also do Carolina games too. I say that I'm actually not going to do any more games I have to travel to. I don't have to. I just do what I want to do, but I enjoy them. Now, I'm partnering with NASA. This Saturday was supposed to be International uh, Observe the Moon Day, and one of the things that NASA and the Astronomical Society of the Pacific is doing is they're asking people around the world that do what I do, other people like me, if I would intern, if I would take on an intern and help them with this hobby, or and the interns are usually in some either in astronomy, in an astronomy major, or or physics major, or astrophysics, or particle physics, or something. They're in the world of up stuff, and I don't know what they would learn from me other than photography and a telescope. But I told I'll be glad to. I'm sure. So at any rate, no, you're not far at all, Ethan. And you too are going to get hit by Eon, Ian, because it's coming up our way. We don't get the real. We won't get the real. We'll get 35 and 40-mile-an-hour gust. But what happens when we get caught in these things is that they spawn off tornadoes, and that's what messes with us, because they'll take down trees. And there goes our power lines, and there goes our power. So there's not a doubt in my mind, none whatsoever, that by Sunday we will not have power. It's just, I just know it. That's just the way it is. We will not have power Sunday. And how long it takes really will have a lot to do with how bad the damage is elsewhere, because trucks come from all over They'll come from Georgia, they'll come from North Carolina, South Carolina, wherever, to the hot areas first. And so I say hot areas, the ones that have been hit the hardest, that have the greatest threat of loss of life due to power line downages and stuff. But Eon, according to the track, is headed right smack dab towards Spartanburg, South Carolina. Right on International Observe the Moon Day. I don't know how many webinars I've had with NASA and the Astronomical Society of the Pacific putting this thing together so we could do the stream. And now it's not going to happen for us. They'll have a successful day, but I won't be part of it. I hate that. I was looking forward to it. I'm photographing a football game on Thursday night with Dorman and Spartan High, Ethan. So they've moved the Friday night game up to Thursday, so I'll be doing that. But anyway, tomorrow night I hope to be live again, and I plan on imaging if skies allow it. And it looks like I'm going to have one more clear night, and then I'm probably going to be fighting clouds for another week. So you won't hear from me live, but hopefully by next Tuesday, Wednesday, or Thursday, we'll be back live with power and some clear skies, and I'll be continuing my attempt to get a better. Oh, the scene has gotten so much better. Jupiter's looking much clearer. It's still, the scene has gotten better, and it changes. It can change and be terrible in 5 minutes. Um, no, we don't have a generator. We downsized 5 years ago, 6 year, 5 or 6 years ago, and I had one there. And my wife and I decided we're just not going to move so much of our stuff, and so I sold all that stuff off, and I sold a bunch of stuff that I knew I wasn't going to have room. We downsized into a smaller house. We weren't going to have room for a lot of things. We had a 3-car garage. Now we have a 2-car, and all that was stacked in. A lot of that stuff was packed into a garage. So no, we don't have one. And our thoughts were we would put a generator in the ground, and so that we would always have electricity. But like plans, some happen and many don't, and that was one that didn't. So no, my son lives here, my daughter lives here, I have a son that lives in Atlanta. I'll just head for power. I'll grab my stuff and I'll head to one of the kids that's got power. Surely we all won't go dark. It's possible, but surely. So we'll head out, take our doggies, and I mentioned last night one of our doggies of 13 years. We found out last Wednesday, that she has cancer. So we're paying close attention to her. There wasn't any option because the tumor was so big. Gonna miss her. She's a sweetie. She was both of our dogs are rescues. She's a Cavachon, a cross between a Cavalier Spaniel and a Bichon. I had never heard of him until my wife brought her home. She was walking the highway. She was on the highway, about to get ran over. And the vet said she had come out of a puppy mill and that she had puppies in her at the time. And she had another little dog following her that looked just like her, must have been one of her children. So we found a home for that doggie, and we kept Annie. We called her Annie, and promised her she would never have to have any more puppies again. And she's been a queen. She's like a throw pillow. We've heard her bark twice in 13 years. That's it. And we like to drop her jaw when she barked both times because she just doesn't bark. She sleeps and eats. Put her on the couch and she stays there until she goes to potty. And she's the throw pillow. But right now she's wanting to be close to either my wife or myself. I think she knows. And as soon as we feel like she's having some distress, we'll go ahead and do what we're hoping, what we don't want to do, but we're going to have to do, and send her on ahead to meet us. We're just going to have to send her on ahead to meet us a little earlier than we wanted to. She'll get to see Jupiter up close real good. Is it too cloudy? It's Vadik is telling me they got clouds where they are. Well, tomorrow night, check and see if you've got clouds because it's going to be huge. It's closest as it can be in 59 years right now, but it'll gradually be a little further away each night, each day going forward. So honestly, when you go out tomorrow and look, you're not going to, if you could see it both nights, you wouldn't know if one was brighter than the other. So go out tomorrow night and check it out. Last night it was just as bright to me as it is tonight. Did the music stop? I really can't tell. That bugs me. I'm just trying to. Yeah, it did. Now it's going. I can see it's going visually. I just can't hear it, and I have no idea why I can't hear it. I don't know. Uh-oh, I just lost. I gotta reopen this. We just lost our connection. After I was telling you about how good this is Splash Top, I gotta reconnect our cameras. The software just crashed on me. There we go. Bummer. And then I gotta open up the other camera. Tell you what I'm not gonna open up is the okay, this is the one. Hey, I needed to check this also. 10 more images of HA, and then we're going to go. Then we're going to some more PacMan coming in. What's my mean is a little bit too high for me right now, which means this is light pollution. I like to get this down around 1,000. So thanks for the subscription. Is it K John 3? Appreciate you. But it's working. So let's see how the guiding's going. We're guiding at 0.55 RMS. What's important when you guide is that your right ascension number and your declination number are pretty close to each other, like 40, 45, 41. That means your stars will be round. When one of these is way higher or way lower than the other, then you get these oblong stars. Whether they're big stars or small stars, they'll be kind of oblong, and they're hard to fix in post-processing. So that's one of the biggies that you look at. Our total RMS is important, but not nearly as important as these values being close, like 40, 40, 39, 41. Then my stars will be good, round, and tight. And I think you'll see when we zoom up We'll go do that. Zoom up 100%. Let's zoom up 200%. How the stars look nice and round, even at the corners. That's great. Very good. Okay, guiding's a problem. This one's working. I don't need to babysit this one too much. Not the case with, they're both on the same page. Let me, how are we going to do this? Let's put this one here, and let's put this one here. No, this one here. And let's just turn that off. I'm getting there, guys. And live streaming. There. All right. Now I think why isn't that doing that? I'm getting there. All right. Okay. You should be seeing Jupiter. Yep. I can confirm you are. That ultimate power box that just came up, this is, I have a box that sits on the saddle of my telescope, underneath the telescope. It's on the rail area, and it's called a Pegasus Ultimate Power Box version 2. And I plug all of my data lines into that and all my power lines. So these are my power lines, and these are my USB lines. And so I have a mount, a focuser, and usually I have a camera and a filter wheel or a flat panel or something else plugged in. And these are the dew heaters that are keeping the telescope warm to keep dew from forming. The temperature outside right now is 62.24 degrees Fahrenheit, and the dew point is 57. Whenever those two cross, as they already have, I can show you they're getting ready to cross. As soon as they cross, then you start getting dew forming on your grass and your telescopes and everything else. So what happens is that these power boxes are set up that when that starts to happen, they start warming up your telescopes. And I have dew straps wrapped around the telescopes and the guide camera. So when it does, it turns on the power for telescope A and B and heats them up, and so dew doesn't form on them. So my glass stays clear, my mirrors stay clear and water free. So these are pretty great things. So power plugs into it, USB, and then I'll only have one power strip coming out, and that's going to AC, and one data strip coming out, and that goes to the computer, and it comes out of the power box. I highly recommend having those if you use this kind of equipment. Okay, we're about to capture 5,000 frames. I don't know how many we've got, but I'm going to wait and till it's finished, and they'll tell me how many we've got left. Okay, we have 9 remaining. So we're taking 20. So we've got 11 in the can, and we have 9 to go. I'm going to drive you crazy again moving these windows around. So Okay, now that I've seen that, let's see. Thank you, TK. Dream, it's not green, it's the atmosphere. When I bring this into post-processing and I color correct it, then it becomes the right color. So it's only green because of I took an image. I took a lot of images of Jupiter last night, and I processed them, and I'll show you one now. If I can, let's see. We'll bring up the. This is an image of Jupiter that I took last night, so you can see it's not green, and this has the great red spot. But this same image, when it was a movie file, looked just as green as the one you're looking at live. So, scene has all of a sudden gotten kind of erratic. And it will do that. It will go from good to bad. Okay, Jonathan, thank you for subscribing, and you're in a great part of the country for having a hobby of astronomy, because you have such you have horizons that you can see the sky 360 degrees. You don't have the trees. You have a lot of areas where you can go. The plains is what I'm trying to think of, the plain states. Good place for astronomy and darker skies. Good farm country. I grew up in central Missouri, Boonville, Missouri. Ethan, Jupiter's color, I went to it a while ago. That's pretty close to what it looks like. When you look at pictures of Jupiter on Astrobin, or you just Google pictures of Jupiter, they're going to look like this. This is pretty much it. And you'll see some that are really, really sharp pictures, Saturn and Jupiter. They take them with these 14-inch mirrors. Mine's an 8-inch. And so when you get a 14-inch mirror gathering light, they're huge. Those are huge telescopes. No, no. I doubt I will. It's 14 incher is it's more than I can handle. It's it's going to weigh three times what my uh, 8 inch weighs, and when I do have to take it down and clean it, it's just it's a beast. Now I've thought about getting a Dobson, and the difference between a Dob and a Smith Cassegrain like that is that a Dob almost sits on the ground, and I could roll that out of the garage. And again, a friend of mine that is a genius planetary imager at our astronomy club is he has it may be an 18-inch Dob, but he can uh, he can get out there. Now this is an 8 inch, which is 2,032 millimeters, and then I have a 2.5 times Teleview Pyramate, which is like a multiplier. So I'm at actually 5,080 millimeters, and I don't get the resolution because I at that at that reach 2.5 times that is I'm at 25. My F ratio is 25, so they're very slow, and that's why I'm only getting like 41 frames a second. I would prefer to be getting 80, 90, 100 frames per second. And if I had a faster ratio than, say, F9 or 10, then I could really be pulling in some quick frames. And I could get by with taking maybe 15, 20,000 frames. But it would take me forever to accumulate 20,000 frames. Yeah, I think I got the music. I can't hear it, but I know how to start it. And this is the first time that I couldn't hear it coming through the earphones. I don't know what I've done, but there's just too many gadgets on my desk that I don't use enough to know how to use them right. Seeing is ridiculously bad now. And if you've been with me for a while, you can see that it is. Look at the bands are real fuzzy, and so that's atmospheric dispersion, transparent moisture in the air. All that stuff's going on, the transparency, dispersion issues, all that's going on between my sensor on my camera and Jupiter. And it's bad now, and I don't know. We'll wait for it to get better. I'm still imaging, and that's why I may only keep, if it continues going back and forth from more bad than good, then I'll only keep 8 or 9 or 10% of the frames. But if they don't turn out, I don't care. I'll do it again tomorrow night, and I'll do it again the next night it's clear, and I'll eventually get what I want. And every year I come up with one, maybe. There's been years when I didn't have a real good image. Uh, in fact, most mine images have gotten better in the last year and a half of planets because of this guy in Roper Mountain Astronomy who's taught me a good bit. He's helped me a lot with how to better do it. How to better do it. What a string of words. Only a redneck from Spartanburg could come up with it. How to better do it. He's helped me. That's probably what I needed to say. Um, that's another problem for me. I've got data that I've taken Ethan going back now over a week because we've had such a run of clear sky nights that I'm. I, I'll show you something I'm working on right now. As a matter of fact, I took the Cave Nebula the other day while I was imaging live, and I decided to start working on it. And can you see this? Okay, I'm in PixInsight, and I'm going to stretch this again. And it's going to take it a second. And so here is the Cave Nebula that I took. Now, it's not going to be green. That's all going to change when I finish processing it. But here are the stars. I shot the stars entirely different. So these are the stars because I shoot the stars as RGB, and then I'll add those stars back to this image after I've removed these stars. See how fat and oversaturated, blown out these are? I'll add these stars back. And how nice and tight and colorful these are. So those are the stars I'll add back to this image when I'm finished processing this. But I started working on this data. As far as the planets are concerned, I just processed that one just right before I went live tonight, and that's this one. Let's see. Yeah, this one here. This is the first. This is the first planet that I processed in a week, or so. No, I did Saturn. I did one of Saturn. Uh, I'll show you. I think I can show you. Oh, what's wrong with these things? Clocking. Ay, 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 ay. I love Windows. I'm on a Mac desktop, but all of my laptops are Windows because all the software for astronomy is written in Windows. So I've had to learn how to run Windows. Let's see, this is from yesterday, and da 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 da. And we did some Saturn, and all right, we'll process a Saturn very quickly. I'm going to open this one up. Well, let me bring up AutoStacker, and let me close this down. I've got some Saturn we can process, and I'll show you how to do one. So I'm going to go to Planetary, Saturn. That's 4,000 frames. I kept 35%. I don't want those though. I want one of these I ran through castrator. So let's just pick this one. And it's trying to load it. There it is. So let's clear this. We don't need this. And let's just go ahead and analyze it. This is AutoStacker, and it's free software. It's telling me that this line, it's not linear, but this line right here is 50%. The 50% line. All of those frames, and this graph represents 5,000 frames. And if I scrub through this is a video. You can see the scrubber on this thing right here. As I scrub through this is showing me what frames I have. Like right here, these are the better frames right here. So this is what I'm going to use for reference. And then this crosses over about, I would say, if this is 50%, and that's 25. Then it looks like it's about 35, 38% right here. So that's telling me that 38% of my frames are above 50%, and the rest of them are below. So I don't want to keep, actually, I would like to keep the top 25%. So in this case, I'm only keeping 15% of the frames. I'm throwing the rest of them away. So we've analyzed it. Now let me put some align points on this, and I'm going to do, say, like that, and let's stack it. So now we're going to stack the image. Folks, hang in with me. We're going to go back to Jupiter in just a minute. We're just going to process one of the Saturns that I did from last night. And we've already done a Jupiter. Okay, it's done, so we can close this out. Now, let's select Saturn. Let's go back to Jupiter. No, so we want to go back to Saturn and 15%, and that's the one we want. And there it is. Let's show it. All right, now the first thing I'm going to do is I'm going to color correct it, and I open this up and check auto balance. So I've color corrected it, and that's pretty much the colors. Then I'm going to run a histogram, and this will brighten it some. Let me close that out. I'm going to bring up this slider to about there and stretch it, and we're going to close that out. I'm going to run a curve, and I'm going to right click and reset this. Right click it again, drag that down a little, and right click here and drag it up. Okay, now we're going to load, we're going to go down here to Saturn, and we're going to pick this preset that I've already created, and there we go. And we're going to do all, and we're going to add some more noise reduction because it looks awfully noisy to me. Probably add some more, and we'll save it as number 1, and there's Saturn. And again, it's not real clear, but it has a lot to do with the scene conditions from last night. So let's head back over to Jupiter, and we're back live watching Jupiter. More than welcome, Ethan. K-John 3, we just did a Saturn, but I have some Saturns that are really good. I think I'm going to stay on Jupiter, but if you'll go to my this is, I'm already there. This is, let's go back to my page, and let's go down to, I know I put some on here. Okay, here's a Saturn that I did last year at this time. So that's one of the better ones. You can see better scene night. You can see the rings real well. And let's see what else. You can tell that this was when I took these. Here's my telescopes. Here's well, actually, I'm using this right now, and I'm using this, and this is the solar telescope. So I'm actually using these two right now. No, this is not the solar telescope. This is the Vixen. This is one my son gave me. I'm using an Astrotech 65 EDQ for that. But they're the two laptops that I'll have plugged in. I don't have, now that I use the Ultimate Power Boxes, I don't have near the cable management problems that I had when I first started. This is an old picture. But actually I went looking for some Jupiters and some, okay. These are pictures I've taken over time. Oh, here's my solar eclipse. This is the one that made all the papers. So this is the see, when I took, this was in 2017, and I said Woodruff. It's in Lawrence, South Carolina, where we took it. Yep. Okay, let's keep on going down. Alright, here's a good Jupiter for me. That's a pretty decent Jupiter for Ed. And so let's head back. And scene has gotten a little bit better, not a lot bit better, but a little bit. Yeah, I know you're referring, Marvin, to the round, tight stars. Yeah, I cheat though. Like I said, I'm going to take my stars, taking, 8 seconds, 10-second exposures for RGB, and then I'm using Star Exterminator to remove the stars, and yep, and add them back. I have some videos on how I do that on YouTube, if you're watching on YouTube. I'm on Facebook and YouTube tonight, again. Yeah, you're right about Jupiter and Saturn being the easiest, but they're brighter. Mars is not a difficult planet to image either. Mars, Jupiter, and Saturn. It's just that by the time you put my focal length on Neptune or Uranus, they're so small, and Mercury is right next to the Sun, so you can only get a picture of Mercury right after the Sun is set, and it's got to be trailing the Sun, so it has to be just right. But it's just so close, and of course Venus is looks like the brightest star in the sky. It's a planet, but it looks like the brightest star in the sky. My phone's gonna die, and that's where I'm reading these comments, so let me plug it in. You wouldn't believe how yeah, Venus is sexy. I guess. I like your stick person, YT. That's awesome. Start the music back up for my dancing friends. Well, I like you too. Ethan, when I first started doing this, and I think 2009, uh, I went like two or 3 years, um, really struggling to get uh, good images, and I've saved everything. I've got an inventory of the sports pictures, but I collect hard drives like most everyone else, and they've gone from the early 1980s from a 20 megabyte hard drive to computers that didn't even have hard drives other than for storage, other than the board. They had external floppies, and so I've kept almost all of those discs, going back to the early 80s. My first computer was a Commodore, then I got a DG1 from Data General. I still have both of them. I bought two, one for the office and one for my home. I was playing chess with a guy from Atlanta who was a paraplegic, and no, he was from Philadelphia. But I used a board. It was an Atlantic user group that I could log on to the board in Atlanta, and he logged on to it. And I would make a move, and I would upload it. He would see it the next day, and he would make a move. He'd upload it, and then I'd see it the next day. And I always got whooped, but I did have plenty of time between moves to try to figure stuff out. I still got whooped. But he was a paraplegic. He had been he was riding in the back of a truck. I think some farm equipment. I think he was. Somehow, if I remember correctly, he was connected to working on a farm as a kid, 12, 13, 14, and got thrown out of the back of the truck and broke his neck and was paralyzed from the... I'm not real sure, but he was able to play chess, but he was pretty much totally irrevocably disabled. And his name was Bearclaw. That was his username, Bearclaw, from Philadelphia, I think. It's in Pennsylvania. I realize how lucky you are at times. How lucky I am. Yeah, I did too. My first job was in Missouri, and I was like 12, and Davisdale Farms would have their hay in bales, and if they thought rain was coming, they would call us, and we were a crew of there's probably 60 or 70 people that would show up. Usually it was the middle of the night. We'd get a phone call, the threat of rain's coming, we need to get the hay up before it gets wet. And we called it bucking bales. We made 3 cents a bale. I was so small, you'd have somebody on the ground, somebody in the truck, somebody driving, and I was so small I couldn't lift them. And so I got to drive the truck, and we were out in fields, just drive up next to the next bale, and they had one of the trucks stacking and one throwing. But I realized then that I wanted to have a career. I didn't want to do this all my life, because the people that were bucking and Chuck, and they were, a lot of them were providing for their families. And a lot of good lessons learned then. It sounds like 3 cents a bale, but man, we put some bales away, and it added up. And I would make $300 or $400 in the summer, which was a lot of money in the late '50s for a kid. Yeah, good point, YT. They sure have changed though. And I pick corn. This sounds like it's awfully self-serving. Uh, like the guy that had to walk to school in the snow 10 miles. But when when the uh, corn picker went by and picked the corn, he didn't always get all the corn, and some of it was uh, knocked on the ground and get ran over by some of the farm equipment. So corn would be stuck in the ground, and they wanted that corn. And so Mama told me, said they're looking for people that'll pick corn, and they paid like by the hour, and I think it was, I don't remember. I'll just be guessing. It was less than $1, 30 or 40 cents an hour, something like that again. Anyway, so I went to the high school. This was during the summer, and I went to the high school where they were going to have a bus to pick up people who wanted to work. And I was wanting to buy a tennis racket. And so I went and got on the bus, and uh, I don't know if there's anybody else my age that decided to do that or not. I don't remember. I just remember I didn't want to do that for a career. And picking corn, I thought was going to be like I did in Mama's garden, and that was walk up and down and just pick it off the stalks. But no, this was get on your hands and knees, and you walk down these furrows, and they look like they went forever. And you'd pick the corn out of the ground because it got ran over, and that's what they used for the pigs. That was food for the hogs. And so you had gathering up the corn, and there I was with grown men and women, all had their own farrow that you would walk down, pulling the corn out of the ground and putting it in baskets, dragging it along, hauling them back. I don't know if I showed up for work the second day or not. I don't think I bought I don't remember. I don't think that was not one of my better career choices. Then my family moved to Florida when I was in high school, and I got a job as a bellboy in a Holiday Inn. That was an experience. I worked all through high school there. Never had so much fun in my life. I think we were the highest paid people at the Holiday Inn. We made more money than the desk clerks. We made we were the highest paid people, apart from the owners, the Williams family. And I have some stories that I can't tell on YouTube. But as a 16-year-old, I bought an Austin Healey 3000 my first year from working there and paid cash for it. Wrecked it and bought a Triumph TR3 with a TR4 engine in it. It's called a TR3A. Drove that all through college. I loved that car. Went to Florida State. Playing football, got hurt. Got a degree in economics and statistics. Like why? I wanted to be a doctor until I took organic chemistry. Look how bad seeing has gotten now. Oh man, this is really what you call terrific poor seeing. Yeah, Ethan, I'm ready to. If seeing doesn't get any better than this, I'm going to finish these images, which we already have done. We're previewing, so yeah, I'm ready to sign off too. I've been on. We've been. This is close to. It'll be 3 hours and 4 minutes that we've been live streaming, and it's been fun. I enjoy meeting all you guys. If you're wanting to see more of the same, subscribe. You don't have to like, but if you like doesn't do anything, but let me know you like it. That's fine. But if you subscribe, then I think you're. I, I they say you need to ring a bell. I don't know anything about that. I've never rang the bell because I can't find the bell. I really haven't looked that hard either. But if you subscribe, when I go live again, I think you get a email or you get notified that I'm on the YouTube, and that is if you're so inclined. Other than that, I am too ready to call it a night, and we'll catch you guys the next time I'm live, which right now is going to be tomorrow night. Uh, and I'll continue to image until the clouds come in from Hurricane Ian, and then I'm going to bunker down and try to protect my equipment. So, uh, good night to everybody.